integers stand for?
They're symbols for whole numbers.
Whole numbers, that's right. So any whole number, so whole numbers are numbers that don't have a decimal, don't have a fraction, they're not fractions, okay? So they're whole numbers, 1, 2, 5, 10, 15, right? These are whole numbers. And they can be positive or negative, okay? So the integers are from all the way from negative infinity to positive infinity, including the number 0, okay? So integers are the set of whole numbers, no decimal, which include negative numbers, positive numbers, and the number, I don't know if we call that a number, but, and the 0. Okay? So an example would be negative 7, 10, negative 150, right? Whatever number, as long as it's a whole number. Okay? Would money be whole numbers? No. Okay? A temperature? No. Right? Number of desks in the classroom? Yes. Right? Number of people at a party? Hopefully. Yeah. You're going to end up with a half a person. All right. Okay. So these are all integers. When adding two integers, the sign, if the signs are the same, then the sum will have the, so let's see this. If I have 5 plus 7, so I'm adding two integer, and both of these integers are positive integer. What is my answer going to be? A positive, right? So that's going to be positive 12. How about if I have negative 5 plus negative 7? So I have two integers, both of them are negative, and I'm adding. That would be a negative 12. Okay? So think about it this way. Negatives are the everyone like, people don't like the negatives. Okay? But when I look at a negative number, I think about like below ground. Okay? Your ground is your 0 level, and anything below ground is negative. Okay? So if you are 5 levels below ground, so 1, 2, 3, 4, 5 below ground, okay? And then you're going down another 7. You're going to be even down more, right? So you're going down 7 more. I don't know how many, so 2, 4, 6, 7, right? So you're going to still be in the negatives, and then you're going to be at negative 12. Does that make sense? Yeah. Sorry? What's the blank? Oh, have the same sign. Okay. Yeah. So if the signs are the same, then the sum will have the same sum. Okay? So you see how negative 5 plus negative 7, I'm getting a negative 12. Right? Positive 5 plus positive 7, I'm getting a 12.
What if the sign was, instead of adding, was subtracting the two negative numbers?
We're going to get to that. Okay, that's a good question. All right, now that all depends on the numbers. Which one's bigger, which one's smaller. Okay? If you have problems with negative and positive, now I mean, yes, we do use a calculator, right? But you also have to know if your numbers make sense. But always the number line is a good start. Okay, look at your number line. So the number line is a line that's horizontal line, right? In the middle you have the 0. To the right you have your positives, right? So to the right of the 0 I have 1, 2, 3, 4, 5, 6, right? 6. And then to the left, I have the negatives, right? And if I am at, let's say, if I'm at -5, so I'm right here, and I'm adding -7, because I'm adding a negative number, I have to go to the left. So because I'm adding a negative number, I have to go 7 units to the left. Okay? If I'm adding a positive number, I have to go to the right. Okay? So we'll talk more about the number line, but also that's a good start for you guys if you don't know what you're doing with the numbers. Okay? So what happens if the signs are different? So let's say I have,
Negative number.
that's right, so it depends on the bigger number. Okay, so let me give you an example. I have -5 and I'm adding 7. Am I going to end up with a positive answer or with a negative answer? Positive. Positive. That's right. It's going to be positive too, and that's because the bigger number is positive. Right? So -5, you're adding 7. You're 5 below the ground, you went up 7. Now you're above ground. Okay? And if I look at my number line, right, I'm at -5 and I'm adding 7. So I'm moving to the right 7 points. 1, 2, 3, 4, 5, 6, 7. Okay? How about if I have -8 plus 3? -5, that's right. Okay? Because my bigger number, which is the 8, is a negative number. So that's going to be a -5. So that means here then the sum will have the sign of the bigger number. Are we okay with that? I really don't like this next statement, okay? I'm not a big person of like, when subtracting two integers, add the opposite. The only reason we're given this is because we just looked at these two examples. But if you have, let's say, what this is telling you, if you have -5 minus 7, right? It's the same thing as -5 plus -7, okay? So basically you're adding the opposite, okay? I'm not a big fan of this method, okay? I usually look at this. I'm at -5 and I'm taking away 7. Where would I be? -12, right? -12, right? Because you're already below ground, 5, and then you're still going down another 7, okay? So you're at -5, and then you're going down more 7, okay? So that's going to be -12, okay? I'm really like not a fan of this part, but. Okay, so this is when you're adding and subtracting. Okay, when you're adding and subtracting, you always have to look at your bigger number and you're going to have to decide what's happening. Especially when you have different signs. Multiplying and dividing, we have a different scenario. Okay? So if the two integers have, let's start with that. So if the two integers have the same sign, then the answer is, okay, let me give you an example before we answer this question. Okay, give me two integers that are positive.
5 and 9.
So 5 times 9. What's 5 times 9?
45.
45. So both of them are positive, right? I ended up with a positive. Right? Okay. Now how about if both of them are negative? So I have -5 times -9. What would be my answer?
45. 45.
Positive or negative?
Positive. Positive.
When you're adding, it's a different story, right? When you're adding, it's not the same as multiplication. That's what you guys have to always remember. Okay? When I'm multiplying two negative, I'm always going to end up with a positive. Okay? So, if the two integers have the same sign, so if both of them are negative or both of them are positive, then the answer is positive. Okay? So multiplying and dividing, they're totally different than addition and subtraction. If the two integers have opposite signs, so positive and negative, then the answer is going to be negative. No matter what the numbers are, always you're going to end up with a negative in this case. Okay? So, if I have negative 3 times 5, negative 15. Okay? When I multiply a negative by a positive, I'm going to end up with a negative. And when I have negative 4 times 2, it's going to be negative 8. Okay? So no matter what number is negative and what number is positive, you're going to still end up with a negative number. So I have this green sheet right here, okay? And remember, this is also with division. This works with division. So a negative times a negative is positive. A positive times a negative is negative. A negative times a positive is negative. And a positive times a positive is positive. So when the signs are the same, you're going to end up with a positive. When the signs are different, you're going to end up with a negative. Okay? And that comes with multiplication and or division. So for example, if I have negative, or if I have 12 divided by negative 6, I'm going to end up with negative 2. Because I have a positive here divided by a negative, so I'm going to end up with a negative. Okay? If I have, let's say, negative 12 over negative 3, I'm going to end up with positive 4. Okay? Are we okay with this? Can I move on to the next page? So the only reason I teach this, I know we all use calculators as I said before, but the only reason I teach this is because I need you guys to make sense of your answers, right? A lot of times the calculators, they add a bracket, some of the calculators, or they work backward, and then you always have to look at your answer and say, well, this is not what I learned, right? If, let's say, you're multiplying two negative numbers and then your calculator ends up giving you another negative, you're going to be like, no, something's wrong here, right? So you always have to think about the answer that the calculator is giving you, right? Just want to quickly go to the next page. So something else that I want you guys to I'm gonna add a page here, so you might wanna use another piece of paper, or maybe the bottom of this page that you have. You can write this note. A lot of times you see something that looks like this. So let's say if I have 10 minus negative 3. What does that mean? So you have 10 minus negative 3. When you have two signs right after each other, you're going to have to take care of that first. Okay? So that two negatives that follow each other, they become a positive. Because I know that when I multiply a negative by a negative, it becomes a positive. Okay? So that's the same thing as writing 10 plus 3. Okay? Now let me ask you a question. If you told your English teacher, I am not coming to school tomorrow, what does that mean?
That means you are coming
That means you are coming to
to school.
school tomorrow. Okay? You use double negative, and using double negative makes it a positive. And this is what's happening here, right? We're using double negative right after each other, right? Which makes it a positive. Okay? So anytime you see two signs right after each other, you're going to have to fix that first. Now, 10 plus 3 is 13. Okay? What if I have this? That looks messed up, huh? And how did you guys do that? How would I simplify this first so I know what the answer is? How would you, if you want to simplify this, how would you write it?
That would be negative 1 times 5 plus negative 2.
Okay, so instead of doing that, that's negative bracket 5. That's the same thing as just writing negative 5, right? I don't need that bracket. It's not needed, right? It's just as simple as it's a negative 5, right? Okay, and then a positive and a negative right after each other, that's a negative. Okay, so you have negative 5, you're 5 below ground, you're going down another 2, so that's going to put you at 7 below ground. Okay, so two negative after each other gives you a positive and a negative after each other is going to give you a negative. Okay, so this is also, if you look at this pink sheet here, that's the same, that's what's written here. So two negative makes a positive, and negative and a positive gives you a negative, positive and a negative gives you a negative, and a positive and a positive gives you a positive. So you can always use these sheets as your cheat sheet if you're stuck. Okay? Are we good with that? All right. Now, I have a bunch of numbers, and a bunch of numbers are added, subtracted, multiplied, whatever, to the power. Can I just randomly select where do I want to start? What do I have to do?
You need to follow the order of operation.
I need to follow the order of operation. Who knows what the order of operation is?
First comes brackets, then exponents, then multiplication and division, then addition and subtraction.
Correct. Okay, so it's, do you know the acronym for it? VEDMAS. Excellent. Hello. You're in grade 11 math? Yeah? What's your name? What is it? So I'll give you this. This is what we're working on right now. We're on this page. And then all right, so you guys are correct. So when evaluating, okay, an expression, you need to follow the order of operation. And by the way, this does not end. Order of operation is not only used in one section of math. It's used in every math section, no matter what you study. If you study trigonometry, or if you study geometry, or if you study algebra or data or whatever it is, you're gonna have to follow the order of operation. So you need to know this like the back of your hand. Okay? The acronym used to help us remember the order of operation is, as you guys mentioned, BEDMAS. And B stands for bracket, E stands for exponent. Now you have to be careful with division and multiplication because whatever appears first. If multiplication appears first, you have to do that first. Then you do the division. Okay? And then addition, subtraction also, you can do it all together. Okay? So for those of you who don't remember this, stands for brackets first. And when I mean brackets, I mean simplifying inside the brackets. Okay? So looking at what operation you have inside the bracket, simplifying that. Then you have your exponents. Then you have your division. Division. Can't even spell that. Multiplication. And these two, in order they appear. So if multiplication, as I said, happens first, then you have to do that first. Then you have the addition. Then you have the subtraction. It doesn't matter, right? When it comes to, when you only have addition and subtraction at the end, you can do them all together at the same time, right? Or you can do subtraction first and addition. It's not going to make a difference which way you do it, okay? But the multiplication and division, they make a big difference. So you have to follow whatever comes first. All right, so let's look at our first example. I have bracket -7 plus 2, close bracket, multiplied by 4.
So it's going to be negative 5 times 4 or negative 20.
Okay, so that's correct. The first thing I have to work with is my brackets, right? I have to simplify what's inside my bracket, and I have to add the -7 plus 2, which is -5, multiplied by 4. Equal should always start at the beginning of this, your mathematical sentence. Okay? So when I'm writing an equal, each line is a sentence, okay? And the equal is like your capital. Okay? So you always start with an equal sign. All right? And then that equals -20. Where would you like to start? At the 2 squared. That's right. Yeah, yeah. Because I don't have any brackets, so I can't touch like this. I'm going to skip that step, right? And now I have to go to my exponents. Where do I have exponent? I have an exponent here at 2 squared. So I have to evaluate that first. Okay? So I'm going to write everything else the same. So 3 plus 16 divided by 2 squared is 4 times 5 minus 4. Okay? What comes next?
Division and then multiplication.
That's right. So you see that I have 3 plus 16 divided by 4, then multiplied by 5. So that tells me, that math tells me, division comes first in this case, so I have to perform the division first, okay? So I have to do 16 divided by 4 first, okay? So that's going to be 3 plus 16 divided by 4 is 4 times 5 Are we good with that? All right? Now, multiplication. And then 4 times 5 is 20.
23 minus 4.
Then you can do the whole thing. You can do it all together, right? 3 plus 20 is 23. Take away 4, that's 19. Okay, I'm gonna add another challenge here for you, okay? So I have the same equation, exactly the same thing, okay? Or expression. I have 3 plus 16 divided by 2 squared, but now I'm gonna put it in bracket, okay? And then bracket 5, and then minus 4. Okay, what do you think would be the order of operation? So exponents, that's right. So I have to do. I have nothing inside my brackets here to simplify, right? So for me, the brackets are already simplified. Okay. So for now, I'm gonna have to leave it like this. Okay. Then I have 3 plus 16 divided by 4 bracket 5 minus 4. Okay. Now what do you want to do next?
Numbers in brackets.
So you want to multiply the 4 and 5 first. Why do you want to multiply the 4 and 5 first before you do the division? Because they're in brackets. Okay? So here's, even though it's 4 times 5, it's still 4 times 5. But when they change it to brackets, okay, then it forces me to do that first. Okay? Now, here's the thing. There are some calculators, if you enter this whole thing in the calculator, it's going to give you 19. And there's other calculators, they're going to give you a different answer. And the other calculators are actually following that you have to do the brackets first, then you're going to do 16 divided by 20. Okay? Why is that and which one is correct? Why is that is because one is, some type of calculators are designed by engineers or programmed by engineers, and the other ones are programmed by mathematicians. Okay? So they have different thinking about what order of operation is. Which one is correct? The one that does the brackets first. Okay? Because if you work it backward, that's a correct way. Okay? Always, if you wanna prove something correct, you work it backward. Okay? And in this case, which calculator is the correct calculator? Is the one that follows the method where I have to do the brackets first, right? Where I have to do 3 plus 16 divided by 20 minus 4. Now this is gonna give me a decimal. I know that. That's fine. Okay, decimals are not something that you should be scared of. Okay. What's 16 divided by 20? I don't have a calculator. 0.8 minus 4, right? And then that's going to give you, so that's going to be see, that's a huge difference, right? If I have a multiplication sign, or if I have two brackets multiplied together. Okay? So you have to be a little careful there. Okay? Hmm? It's because 3.8 and then take away 4, so the 4 is bigger.
Oh.
Okay, so do you add the 3.8 first and then minus the
Yeah.
4?
It doesn't, in this case, it doesn't matter which one.
Adding first, okay.
It doesn't matter which order you do it, but I usually go from left to right, from the left to the right. And then 3 plus 0.8, that's 3.8. Take away 4, that's negative 2.2.
Okay.
Right?
In this case, we did first exponents.
Yes.
and then brackets.
That's right. So we did the exponents first, and then I had to do the brackets because the brackets are multiplied. Okay? So I had to do this bracket multiplication before I do the division. I know. This is one of the trickier parts, okay? And then at the end of the day, I'm doing the same question, right? It's just change it a little bit, change the bracket, it changes the whole thing.
Because now the bracket means multiplication.
Yes, the bracket means multiplication, but because I put it as brackets, it forces it to do it first. Okay? What I want you to do is pull out your calculators and then put this in your calculator with brackets and then put it without brackets and tell me what you guys got. I would like to know your calculators. Pull out your calculators and then I want you to, first, I want you to try entering in your calculator this one. Exactly the way it's written. No, it's not negative.
Oh.
This is just I was writing an equal sign and an item. Okay? So enter this in your calculator. I would like to know your calculators. Oh, phone calculators? No. I will accept it for the first day.
Yeah.
And as of Monday, we're all going to have good calculators. 19, even though you entered it like exactly like this.
This is financial.
I got negative.
I can show you like different kinds of calculators that you guys can buy, but not phone calculators because they work backward and they're not going to help you when we get to the big, huge formulas. No, not the graphing ones. No. Okay. Do you have a what division did you put? Did you put this one? That's a mathematician design yours. Okay. Someone else. What do you guys get? Huh?
I got negative.
You got negative 0.2? Okay. Okay. So, Miharat's calculator gave her, entering it this way, gave her 19. Okay? And I did check it. And then, Ahmad's calculator gave him negative 0.2. What do you get? You got 19 as well? You see? Even these are two scientific calculators. Okay? They give you two different answers. And that's why I want you guys to try with not only entering things in the calculator and not thinking about if the answer is correct or wrong. I want you guys to think about the method and the order of operation and think about, well, no, I have to do this by hand. Okay?
So how does that just tell you which one's like the engineer? And
Yeah.
then
Mathematician?
That's the method.
They're, unfortunately, I don't like to say this, but they're not the correct. And then engineers. Oh, yeah. All right. Where is my pen? vacation, no brackets. Okay? Or you all can try that. And please, please, please make sure you get a good calculator. There is like, is your calculator backwards?
Have to get a better one, miss?
Yeah. You know why? Because then when we get to the trigonometry, you guys are gonna suffer. Okay.
I ain't paying no $20.
How much did you spend on this?
$1.50.
I can imagine. Okay,
I can imagine.
because they're backward. Okay, so for example, this one, I don't know how much this costs, but this is a good one. Okay?
I know.
Uh,
Bro, ain't this been 11 math?
What, sorry?
What from each
Where you can get it from Staples, from Amazon, from anywhere. This is the best calculator you can ever buy. It's about, right now on Amazon, it's for $17.99. Delivered, like, this is how much it is. But I mean, you can use this
But then you have to wait for it to come in.
if they have like Prime,
Oh, Prime comes in a day.
$29.